Hello class. This lesson we're going to learn about the perpendicularity of segments, and we're going to learn how to apply normal segments. As a warm-up, Carlos thinks that these two segments are perpendicular. Do you agree with Carlos? Why or why not? So try this on your own and I'll show you my solution. Well, one way to check is by using slope. We know that if the slopes are negative reciprocals, or if we end up with a slope of 0 and one that's undefined, then they will be perpendicular. In this case, both slopes are 0, so they are not perpendicular. And it's clear from the picture that they're not. Now, there's another way we could have done this. In the previous lesson, we learned about this formula. Right? If both segments have an endpoint at the origin, then if we multiply the x coordinates and add that to the product of the y coordinates of the points that aren't at the origin, that has to be 0. And if we check using the points that they give us, we end up with -12, which is not equal to 0. So we want to do the same thing, but now we have segments that don't have endpoints at the origin. So how can we figure out if these segments are perpendicular and if the lines that contain them are perpendicular? Well, the answer is either going to be yes, yes, or no, no, because by definition, when the segments are perpendicular, lines that contain them are perpendicular. So we could use slope here, right? And if we figure out the slope of the line that contains segment AB, we get 7/4. And so the negative reciprocal of that is -4/7. And that is indeed the slope of line CD. So these lines are perpendicular, as are the segments that they contain. Now there's another way we could do this. I tend to think that the slope method is a little bit simpler than the other method, but I still want you to see it just so you can see another application of the theorem from the previous lesson. So in general, we're not going to do these problems this way, but it's always good to know more than one strategy. So another way we could do this is by translating each segment to the origin. Once they're at the origin, then we can use our theorem. And translating to the origin isn't going to change the angle measurements. So if those at the origin are perpendicular, then the original ones are going to be. So to translate our segments to the origin, one way to do it is, for AB, we're going to move A to the left 2 and 2 down. So we'd have to do the same thing to B. And we end up with the point B prime is 8/14. For C, to get it at the origin, we'd move to the right 3 and down 1. And so we do the same thing to D, and that gives us D prime is 7/4. And now we can use points B prime, and D prime in our formula. And we should get 0 because we already showed that these are perpendicular. And we do get 0. So I tend to think that the previous way is a little bit simpler, but now you have another way of solving this type of problem. So for the rest of the lesson, we're just going to look at slope. And here's some vocab that's going to help us out. Mainly normal segment, but here's some vocab that you might have missed before. And abscissa is the word for the x-coordinate of a point. And ordinate is another term for the y-coordinate of the point. You don't hear these too often, but they do pop up sometimes. Now, a normal segment is what we're going to be focusing on the rest of this lesson. It looks like this, and it's a segment that is perpendicular to a line and also has an endpoint on that line. So a segment AB is a normal segment to this line AP. Now, maybe you're thinking, why do you use the word normal? It doesn't seem very normal. Well, not in that sense of the word, right? Normal as in regular, but there is a sense in which regular means a right angle. And if we look at the etymology of the word normal, it comes from the Latin norm, which literally means a carpenter's square. So carpenter's square is this object, and it looks very similar to what we get with a normal segment. So that's where it comes from. So if we have a segment, how can we find the equation of a line that goes through one of the endpoints and is perpendicular to it? So we want to make the segment a normal segment. Well, there's a strategy we can follow. We're going to come back to the example in a moment. First, we want to figure out its slope. Now, if it turns out that the slope is either 0 or undefined, all we have to do is use an equation of the form x equals or y equals and plug in the correct coordinates. If, however, it's not 0 or undefined, we have to look at the negative reciprocal of the slope, because we know the line with the negative reciprocal is going to be perpendicular. And then we're going to use that slope along with either point slope form or slope intercept form to figure out the equation of a line. So we're going to practice both methods when we get to it. You're responsible for knowing both. An answer could show up in point slope form or in slope intercept form. So you really should know both strategies. So let's go back here. What is the slope of segment PQ? Calculated slope, and it ends up, it's undefined. So we know that's a vertical segment. So the line that's perpendicular to it has to be horizontal. So it has the form y equals. So if it's passing through P, the y coordinate of P is 4. So that gives us y equals 4. I'm going to do the same thing, but this time using point Q. So the slope hasn't changed at all. So it's still y equals, right? We want a horizontal line. And let's see, if it's going through Q, then the y coordinate will be -1. Okay, similar idea here. What's the slope of this segment? The slope is 0, so it's horizontal. So we know the perpendicular lines are going to be vertical to it. So vertical lines have the form x equals. And let's see, if it's going through V, the x coordinate is -3. X equals -3. And we want to do the same thing, but this time with W. And so it's going to be x equals. And if it's going through W, the x coordinate is 7. So x equals 7. In this example, let me zoom back in. When we calculate the slope, we do not get 0 or undefined. What do we get in this case? We get 3, or 3 over 1. And so if a line's perpendicular to it, its slope would be -1/3. Right? Take its reciprocal and take the opposite sign. So 2 different ways we can find the equation of a line that's perpendicular that goes through A. We can use point slope form. And since it's going through A, we would use the point 5, -7. And remember, when you plug into this formula, it's minus, so you got to flip the signs. So we would get this equation. Now, maybe you don't like point slope form. Maybe you want to write it in slope intercept form. And so to do that, we can, if we're going to start from scratch, forgetting that we already did this work, we have the slope is -1/3. And we want it to go through the points 5, -7. So we're going to plug in 5 for x and -7 for y. And now you can solve for b. Ends up being b is -16/3. So we plug that in and we get this equation. Both of these formulas are exactly the same. If you simplify point slope form, you will get the slope intercept form. So these are both correct answers. Similar idea, but now we want to talk about point B, which is 8, 2. And so now when we plug in the point slope form, the slope is still -1/3, but now we have the 8 over here and the 2 over here. And if we want to use slope intercept form, you would plug in 8 for x and 2 for y. And you solve this and you get this equation. And once again, both of these are exactly the same, just written differently. In this lesson, we learned how to figure out if segments are perpendicular, and we learned how to apply normal segments. Thank you for watching this video.